This axe has a secret hidden inside its iron head, a strip of high-carbon steel welded into the cutting edge. Vikings could not make entire weapons from expensive steel, so they invented a brilliant metallurgical trick. The Viking war axe was the deadliest close combat weapon of the early medieval period. Unlike swords, which were expensive status symbols, axes were the weapons of common warriors and raiders.
Common warriors with axes defeated armored knights? The axe was clearly underestimated by history.
The head was forged from wrought iron, which is soft, tough, and easy to work but poor at holding an edge. A thin strip of high-carbon steel was then forge welded into a slit cut in the iron at the cutting edge. Forge welding heats both metals to white heat, then hammers them together until the atoms actually bond. The carbon in the steel edge creates a harder microstructure called martensite when quench hardened. Martensite is one of the hardest structures in steel created by rapid cooling that locks carbon atoms in place.
Rapid cooling locks atoms in place, so the cooling speed literally determines how hard the steel becomes.
The soft iron body absorbs shock without cracking, while the hard steel edge cuts and holds its sharpness. This is the exact same principle used in modern composite cutting tools. Tough body with a hard working edge. The bearded axe or skagox had a downward extension that hooked shields and pulled them away from defenders. The Dane axe had a massive thin blade up to 18 inches wide on a 5-foot haft for devastating two-handed swings. Despite its size, the Dane axe head was remarkably thin and light because it was designed for cutting, not bashing. A thin blade concentrates force on a narrow edge, creating enormous cutting pressure per square inch. The long haft provided a mechanical advantage, multiplying arm force through leverage at the moment of impact.
5 feet of leverage swinging a thin, sharp edge? The cutting power must have been absolutely devastating.
Viking smiths also used a technique called piling, where rods of iron and steel were twisted and forged together. This created visible patterns in the metal that Vikings believed held mystical properties from the gods. In reality, the piling homogenized carbon content, creating a more uniform and reliable steel throughout the blade. Archaeological analysis of Viking axe heads shows carbon content precisely controlled between 0.6 and 0.8%. This carbon range produces the optimal combination of hardness and toughness for a cutting weapon. Viking-era bog iron was smelted in simple bloomery furnaces that produced inconsistent, spongy iron masses. Smiths had to repeatedly fold and hammer the bloom to drive out slag and homogenize the metal structure. The axe was also a daily tool used for woodworking, building ships, and clearing land when not in combat. This dual purpose meant every Viking warrior was intimately familiar with his axe through years of daily use. The Viking axe proved that metallurgical ingenuity can make a common tool into a weapon that terrified all of Europe. Real science, real weapons, look it out.